So if we recall from previous videos, we looked at and analyzed what the different subatomic particles contribute to the atom. And the proton contributes the positive charge, which is very important in terms of determining a given element's characteristics and chemical properties. It also contributes approximately 1 atomic mass unit, or AMU, of mass, so it contributes significant mass to the atom. The neutron, in general, does not contribute a lot to the chemical properties of a given atom. There's some cases where having too many neutrons will make the atom unstable, but in general, the neutron is not the most important particle in terms of the atom's chemical properties. However, it does contribute approximately 1 atomic mass unit as well of mass to the atom. So it's very important in determining the mass of the atom. When we look at the electron, if we recall, the electron is very important in terms of the chemical properties and reactivity, specifically of an element, because it contributes the negative charge. However, its mass is relatively insignificant, 1/1840th of an atomic mass unit, or AMU. So I say all of that because when we talk about the mass of an isotope, the way to find the mass of the isotope, and this, of course, is coming from one of the versions of the njctl.org presentation on atomic structure, we see here that the way to find the mass of an isotope is to add up the mass of the number of protons and the number of neutrons, because it's 1 AMU per proton, 1 AMU per neutron. So we can just simply add up the number of protons and neutrons to find the atomic mass of the isotope. So now, usually you know the mass of the isotope. And because you know the mass of the isotope, we can put down here a formula: protons plus neutrons equals the mass of the isotope. Normally, we know the mass of the isotope. We know neon 20 has a mass of 20 AMUs. Neon 21 has a mass of 21 AMUs. Neon 22 has a mass of 22 AMUs. So what we're looking for many times is not the mass of the isotope. We're looking for the mass of the neutron, and the number of neutrons, rather. So really, and it's not even the mass of the neutrons, it's the number of protons. It's the number of neutrons, because each proton and each neutron is approximately equal to 1 AMU. So how do we find the number of neutrons? What we're going to do, if we have this mathematical equation, we know to get the number of neutrons by itself, we simply, if we're adding these values together, the opposite of addition would be subtraction. So we're simply going to subtract the number of protons from both sides. Subtract the number of protons from both sides of the equation. And when we subtract the number of protons from both sides of the equation, what we end up with is simply an equation that looks like this. The number of neutrons is equal to the mass of the isotope minus the number of protons. Now, how can we represent that in a slightly shorter form, which is often done? What we can do is simply say N0, because the neutrons have no charge, equals the mass, and that's understood that it's the mass of the isotope, not the average atomic mass, minus P positive, because we know that the protons have a positive charge. So that's how we would find the number of neutrons for a given isotope.